Hello, chemistry students. Today we are going to talk a little bit more about the properties of ionic and covalent molecules. So these are the two examples we talked about in the last video. We talked about water and sodium chloride, or table salt. Water is an example of a molecular compound. The three atoms in the molecule of water act as a single unit. So you can see here they have lots of single water molecules that can move whichever way they want to. They can change their orientations, and they mostly just float around, especially in the liquid state or the gas state. It's a little more packed in there in the solid state, but they act as single water molecules. Now, the sodium chloride is an ionic compound, and the ions in its formula do not act as a unit. They exist as an array of ions, so that sodium and chloride stack is formed with these ions. And I just wanted to remind you of this. This is the atomic level difference between molecular compounds and ionic compounds. Now, last time I told you how to recognize whether a bond was ionic or covalent. Remember that ionic bonds are formed between a metal and a nonmetal, right? And then covalent bonds are formed between two nonmetals. So nonmetals only in covalent bonds. That's the first way to determine whether you have an ionic or covalent bond. The other way you can do it is using electronegativity difference. So we're going to go over how to do that calculation. The electronegativity difference between two elements can tell you which bond is most likely to form. Remember, electronegativity is the ability of an element to attract electrons when in a compound. So it's how strongly that element pulls electrons in. So notice that fluorine's electronegativity value is 4 because it pulls it very strongly. It is the most electronegative atom, whereas cesium's electronegativity value is just 1. Remember that cesium is a group 1 element, meaning it has 1 valence electron, so it is not pulling more electrons toward it. It mostly just wants to get rid of that electron. Okay, so the way you calculate the electronegativity difference is you take electronegativity A, or the electronegativity of the element with the larger electronegativity, and you subtract that from the electronegativity B. That just gives you the electronegativity difference. Now, what you need to write down is that if the electron negativity difference is greater than or equal to 2.0, it is an ionic bond. If the electronegativity difference is less than 2.0, it is a covalent bond. So I would recommend that you copy down what's highlighted in blue on the left, and you might also want to copy down this electronegativity table I have on the slide for you. Okay, so let's practice. Are the bonds between these atoms ionic or covalent? Starting with hydrogen and bromine. Okay, so we would have 2.8 minus 2.1 equals 0.7. So this is less than 2.0, so this is actually a covalent bond. Okay, so next let's do Potassium and chlorine. The electronegativity difference is 2.2, so this is an ionic bond. Okay, carbon and oxygen. This is a covalent bond. Chlorine and fluorine. Another covalent bond. Lithium and oxygen. This one is ionic. And last, bromine and bromine. Clearly a covalent bond.